First, I'll open the right. So far, what we have done with this presentation. So I'll share it first. Hope you can see this presentation and the slide movement as well. Can you able to see it?
Yes,
Yes,
sir.
sir.
Okay. So far, what we have done is we have discussed with the analysis of the IPv4 header, and we have gone to this the cost that we how we are going to analyze the cost and type of services, and what are the type of services available that you can configure in the address network packet. And then so we just discussed about the these three things: version, header length, service bit, and the total length. So hope you are clear with this particular concepts, like because now we are going to discuss about the next three things together, because as I told you, these three things we have to discuss together. Otherwise it's no point of discussing it, because these three things are in the same page, like same page in the sense what they are discussing is if you want to look at what they are going to use it with this identification flags and the fragmentation offset, these three things are working in a same line, same manner. It's like a sort of a cousin brothers. So if you miss anything, so we can't get the understanding of the data packet. So these three has to be work in the same manner, same line, and that should provide the sort of a fully working IPv4 header packet as well. So this is what we are going to discuss now. Let's move to the that particular part. Okay, so when you dealing with this the identification, nothing much, but what they are going to do is I have told you that let me check this, just share the entire desktop environment. I just explain you that right. So let's I have told you that whenever you are going to deal with the environment, if it is you are dealing with the Ethernet environment, the maximum size that you are dealing with is 1500 byte. Didn't we discuss this one? I guess we have discussed it. So when it comes to the 1500 byte, what you need to understand is, of course, since we are having the 20 bytes for the IPv4 header, that is we call it as IHL. So the maximum size of that we can send through the IPv4 data packet through when you are dealing with the IPv4 and the plus the data. So the total length that we are going to send it here is 1500 byte, and out of that data will contain 1480 bytes. So this is what we are going to do. As I told you, whenever you are going to run, let's say for example 4500 bytes packet, is it possible to send this 4500 bytes straight away through the um, Linux, sorry, hello guys, hope you can hear me, right?
Yes, sir.
Yes, I can hear you.
Okay, so because I have switched the network link from one provider to another one. So so just tell me that, so if we were going to send the 4500 bytes packets, how we are going to send along the Ethernet channels? Does it possible to send the all the 4500 bytes including in one single data packet and send it there?
No,
No, sir, impossible.
So how we are going to do it then?
we have to fragmentation use.
Exactly, since the Ethernet communications have the sort of a what we call limitations. So this is actually differed from the different. As I remember, I have discussed this thing. So this will be very like the number of the packet size that we can send through the different channel will going to vary. So this is exactly the values that is we call as an MTUs. Rather we call it as a this is the MTU or maximum mission unit. MTU. So since we basically dealing with in our world, we are dealing with let's just think about a, a, a cake which are having on, let's say for example, whenever you want to put it into a box, so you need to cut it in the pieces and put it into the box. So that is simply what you are going to do, because there is in the box they have a limitation that the maximum size that they have they can put it, so otherwise we can't put that down. So the simple thing what we are going to do here as well, so we are going to chunk it. That is in technical world we call it as a fragmentation. So basically when they are going to chunk this one, you need to look at, okay, the size of the data IPv4 header, and then rest will be the data. Rest will be the data. So this is how they are going to chunk it. So now if you look at this 4500 bytes data, whenever they are going to chunk it to 20 bytes plus the IP header and the 1480 byte plus data can be included into the one data packet. Then next data packet, next IP header will be included 20 byte plus 1480 bytes of the data. So now you have already the data that you have included is 1480. Let's get the calculation here. So 1480 plus 1480, you will be seeing, sorry, what has happened there? 1480 plus 1480. So you will be thinking now it's already consumed 2960 bytes from the data. Next data packet again will be 20 byte plus 1408. So the bytes that is again once you add it up, so 1480 bytes, so that is going to be 4440 bytes. So there is another 60 bytes. So what they are going to do is remaining bytes will be added to the next data packet. So 60 bytes. So this is now you can see this packet, this particular data packet. Whenever they are going to send this data, when they are going to send this data, you can see that they have chunked this whenever they want to send the 4500 bytes of the data, they break it into the 1, 2, 3, 4 data packets, including the IPv4 header. Then only they are going to send it. So now, let's say in a given time, we just take a simple example that we are sending 4500 bytes data. In a given time, just imagine it is not just sending a single data like 4500 bytes data. It might send definitely they are sending the multiple data. So whenever you have received those data, let's say for example this data will be sort of a let's say download of YouTube. So there is another type of data that you are accessing Facebook. So in that case also you are getting the data. So what will happen if the YouTube data packet and the Facebook data packet have been shuffled and received by the end parties? So what will happen? Some data set will be having the Facebook content data, some data set will be having the YouTube content data. Obviously it's a shuffle, obviously it's a data corruption. So because they cannot reconstruct the original data set which have been sent by the server. So they are having a sort of issue that they are in a mess, a confusion where what to do. Of course, in that scenario, what they are going to do is they will be going to discard that type of corrupted data because they can't reconstruct the data again by getting the chunk data. So in that scenario, in order to remove that sort of a data shuffling, they have introduced the identifications. Along with the data packet, they are going to do a sort of a unique ID likewise. One. So all the data packet will have that unique ID. One. So now if you have the unique ID 1, they will look at the unique ID, that the identification flags. Based on the identification flag, they are going to do a reconstruct the data, because they are not big, because since they do have the identification flag, they can identify the same data set and send it to the intended recipient. So in that other case, let's say the second set of data have the identification flag of 2, so they get together the second data set and send it to the intended recipients so that they can reconstruct the data set from beginning. So that is the whole purpose of identifications that we are going to use. Are you clear, guys?
Yes, sir.
So do you have any issues?
So එතකොට මේ හැම පැකට් එකටම මේ data පැකට් එකටම එකම ID එක sir එන්නේ.
Data එකම ID එකද කියලා කියන්නේ මොකටද ඔයා කියන්නේ?
So දැන් fragment කරනවානේ කොටස්.
ඔව්.
එතකොට අර receiver end එකේදී
ඔක්කොටම ඒ කියන්නේ එකම data set එකට එන්නේ එකම identification flag එක.
හරි සර්.
ඒක වෙනස් වෙන්නේ නැහැ. Clear the guys? So second thing is the IP flags. So this is one of the important thing that is in header, that is called in this IP flags. It's having the 3 bits. On the 3 bits, they do have 3 different IP flags. One is the first one is reserved for the evil bit, that is we call it a evil bit. That is they are not going to use in any purposes. It's reserved. The second one and the third one in the IP flag is the more important thing. This D flag stand for do not fragment. The M flag stand for more fragments. So I'll explain what are the meaning of these two things. So just give me a second, guys. Just give me a second. Right. Okay. So I'll explain that further. Let's look at this is the first data packet. in this particular scenario, this is we are going to do the first data packet. This is we are going to do the second data packet, right? This is we are going to do the third data packet in the same data set, and this is what they are going to do is the fourth data packet. In here, in this particular data packet, defragment in the sense, do not fragment, and M flag is the more fragment. Here, they used only two values. One is either the 0 or the 1. 0, if they have used the 0 stand for enable, 0 stand for disable, and the 1 stand for enable. So here, what they are going to do is, in this data packet, D flag definitely should set to 0. M flag definitely should set to 1. That means what they are saying is, we are asking, do not fragment, disable it. If you say do not fragment, what they are going to do is, they are going to stop the fragmentation. They are going to stop the chunking. Is it clear, guys? More fragment, definitely we require more fragment on this data packet, because otherwise we can't send the 4500 bytes. Just include only 20 byte plus the header and the data of 1480. So in the first data packet, what we are saying is, they have on the do not fragment disable, more fragment enable. In the second data set, in here also, defragment do not fragment should be disable, more fragment should be enabled. In here also, do not fragment should be disabled, more fragment should be enabled. In the last packet on here, do not fragment should be enabled. That means no fragmentation is required from this point onwards. More fragment should be disabled. Are you clear, guys?
Yes, sir.
Yes, sir. Yes, sir.
What about the others? Because I need your clarifications. There are several questions related to this. Yeah, if you do have any type of, if you are facing that the thundering and the heavy raining, so obviously you can consider of log off from the session. That is actually fine, because otherwise you will be lose your valuable devices if they go caught to the thundering and the thundering simply. So you can consider of that one as well, because even here also, in my place, in here also, now it's not raining actually, but thundering and the storming is sort of a thundering will be there. That is definitely there. Yeah, the lecture will be definitely missed, and as well as I have planned to have the assignment as well. So okay, you guys can just log off from the session. So if I'm going to have the assignment, so definitely I will inform you through the WhatsApp group. So otherwise your friends also can inform. So that is can be done there. Right. So So this is what exactly what I'm expecting here is the do not fragment and the more fragment. Guys, do you clear this? Are you having any issues, concerns related to this one? Let us do another one, another exercise. Actually, these are the practices for your exams as well as your guided exercise. So we have, let's say, for example, 6,580 bytes of data. Just think about the data. So whenever we need to do the fragmentation, so the first, this is definitely we need to do the fragmentation before we sending it. So we have included the first internet header length, that is IHL is 20 bytes plus 1480 bytes. Sorry guys. Then from this data packet, the D flag and the M flag, what they are going to do? Do not fragment. Does it disable or enable? Do not fragment means do not fragment. No fragmentation is required. Do not fragment is no fragmentation is required. If you enable means there is no going to have the, simply they don't have any fragmentation from that point onwards. That is what exactly mean by the do not fragmentations. There is no fragmentation is allowed from that. M is the more fragmentation. If you enable it, that with the one, that means we need more fragmentations. The fragmentation is allowed. So that is what exactly means. So from this packet, what is the going to be the, does we require the more fragmentation or not? Of course, we require the more fragmentation. That means we set to no do not fragment is set to the 0, more fragment set to the 1. Then again, the next packet is going to be the 20 bytes of data plus the rest of the 1400 bytes from the data set. In this data packet also, do not fragment is set to 0 or more fragment is set to 1. Because we need more fragmentation, definitely do not fragment or no fragment is should be disabled. In the next one also, we have the 20 bytes of data plus 1480 bytes of 20 bytes of IP header plus the 1480 bytes of data. Do not fragment set to 0 and the more fragment is set to 1. Next one also 20 bytes plus 1480 bytes. Again, do not fragment is set to 0, more fragment is set to 1. Because still we couldn't complete all the data set because it's contained 6,580 bytes. So if you look at every content in here, now we do have 1, 2, 3, 4. Of course, 1480 bytes. Sorry. 1480 bytes into 4. Let me check that. 5920. If you reduce the next thing 6580, so it's only 660 bytes. So the next data packet, that is the last data packet of this particular data set, 20 bytes plus 660 bytes. In this particular data packet, do not fragment is should be enabled, more fragment should be disabled. So always keep in mind, if you see the flags like do not fragment disable and the more fragment enable, that means either it can be the first packet of the data, first data packet of the particular data set, or it can be the middle, like this one. So these are the middle data packets. If you are giving a data packet with the D fragment is 1 and the M fragment in N flag is 0, that means do not fragment is enabled. That means that is going to be the last data packet. Are you clear, guys? That is going to be the last data packet. So someone raise hands. So what is the issue, guys? Which part that you need to explain it again? So if you can just send me the but is this that you required the this fragmentation and the more fragment concept, so then I can definitely explain. Is it what you are requiring to explain it? uh, 560 or 660, let me check that one. It might be some calculation issues, not no worries about it. So let me check that one. So I guess just if you can chat me also, that is fine. I guess everyone is clear, right? So the people who have been asked to explain it again.
සර් ෆ්‍රැග්මන්ට් කරේ
Okay.
නැත්නම් මේ ඩෙන්ටිෆිකේෂන් නම්බර් එක ඇඩ් වෙන්නේ නැද්ද සර්?
නෑ නෑ ඒත් දෙනවා. මොක කරත් දෙනවා. මොකද segment නොකරත් දාන්න ඕනේ. අනිවාර්යයෙන්ම identification number එකක් තියෙන්න ඕනේ. So even though that packet is fragmented or not, definitely even for the single data packet, they are going to add the identification. That is identifier. It's like you are sort of a NIC number. So it's a unique identification. Clear, guys?
Yes sir.
Hope you were okay. Let me check the questions. So whether it's a 660 or let me check that one. Or the 560. So here, just get again. We have gone through 1480, 1480, 4 times. So there are 4 times of 1480, 592, 5920 minus 650, 6580. So it's exactly 660. If I'm not mistaken, this is the calculation. So it's going to be the not 560, it's a 660. So because it's a data size is 6580. So we will be not right. Okay, I guess this is what you actually have mistakenly understand. We are not calculating because we just calculate the data only. Here it says the clearly data, not the header sizes. That doesn't include the header sizes. So when you want to calculate it, you need to get the data sizes only. Fragmentations, you have to take the data sizes, not the whole packet. Like say for example, if you take 1500, so the 1500 might contain, as I mentioned you, the IPv4 header plus the data both. So here what we are referring is the data only. So not the 1500. If you calculate 1500, obviously it should be the 1500, 1500 into 4, that is 6000. And if you divide it, reduced it, that is going to be the 580. That is not the exact answer. So I guess you have made the calculation based on that, not like that. The calculation has to be done by calculating the data, because here it clearly mentions 6580 bytes of data, not the header they are going to discuss. Are you clear, guys?
Clear, sir.
Yes sir.
Ethernet header, that we are not going to discuss in here because it's not fitted into the here. So because Ethernet header will be added on the next the lowest level, like on the layer 2, not in here, because that we are not going to use it. So it's not like this. Ethernet header is a separate header that they are going to add once your data packet is being moved to the second layer, not in the third layer. So in this, when you say the maximum transmission, you need 1500 bytes. That is what they are saying is 1500 bytes. They can send it through the network layer. Are you clear?
No,
Sorry,
sir. Not understand.
you didn't get it right. So what? See here, I'll explain that one. So in here, so what we are right now is using here is, so I told you that we have a layer 7. So the 7 layers when you're dealing with layer 1, 1, 2, 3, 4, 5. So here 1, 2, 3, 4, 5, 6, 7. So when you're dealing with these 7 layers, the maximum transmission unit that they are talking about on the network layer, not in the, when you say Ethernet framework will be added in the layer 2, because once they receiving this one in the layer 2, they have already added their network layer. They will be added the framework Ethernet frame, which is going to be sent it like a, it's like a sort of a wrap which is going to be your, like is it some, let's say you are going to the ticket to the maximum weight that you can carry out through the plane. So normally that is the 30 kilogram from the baggages, and 5 kilogram from the hand is the baggage, main baggage, and the second one is the hand luggage. They are going to go for the counters for the checking, for the checking. They will be definitely look at the, they will weight the your bags, so the hand luggage as well as the baggage. So whenever they are going to weight your bags, the bag, if the bag, so let's say for example, you might have the bag which is consistent of 30 kilograms, exactly 30 kilograms on the baggage. And in some cases what we are going to do is, if that baggage, if your baggage having sort of a fragile devices, fragile things, what we are going to do is, on the entrance of the airport we have a sort of a wrapping facility. What we are going to do is, we are going to wrap up the whole baggage by using the wrappers. So there are wrapping facility that I'm not quite sure how much that will cost, but what they are going to do is, they will add an extra layer of wrapping, and they will secure your baggage. So that is what exactly going to do. But by adding that one, that doesn't mean that you will, when you add the wrapping also, but once you wrap up that one, still the baggage can contain 30 kilograms. So that the wrapping weights will not going to measure in that scenario. So that exactly same thing happen in your Ethernet header as well. Is it clear now, guys?
Yes, sir.
Being on the layer 2, because that doesn't make any sense, because they don't know what is the maximum transmission unit, what type of things they are going to use. That is not going to measure there. So they will definitely add the Ethernet framework header of the 14 bytes, that is going to separately counted measures there. Clear, guys?
Yes, sir.
Yes, sir.
Okay, great. So guys, again I'm telling, if you do have any sort of a lightning issues, you can log off, huh? Right. So I hope that you will be cleared with the identification IP flags. Now we'll be going to move with the fragmentation offsets. Are you clear, guys, with this one?
Yes, sir.
Okay. So I'll take a example here to explain the fragmentation offset. Why we are you going to use the fragmentation offset and where we are going to use it. So here, just take an example as this one. This is your original IP datagram. This is your original IP datagram that is containing total length of 5,140 bytes. 5,140 bytes. Just tell me, when you have the 5,140 bytes, how this is going to be happens, how they are going to fragment this particular data set. Yeah, that is exactly correct. So if you are having, let's say 1,500 bytes of the data, of course, it does not require to do any fragmentations. Definitely, no fragmentation is required. The first fragmentation will be enough. That that is they can go ahead. Okay, guys. So I'll explain that again from the beginning. So this is what I want to highlight here. The fragmentation is something like this. Since the network that the devices, especially the routers, switches, and the network adapters, having the issues, concerns, like they do have defined with the code into the network design that you are using, based on the network design that you are using, they have sort of a describe uh, a maximum transmission unit, MTU. The MTU that we are going to deal in our environment is most 500 bytes will include 20 plus 20 plus 20, 20 to 60 byte of IPv4 header and the real data. So when you calculate this thing, so because I told you that data IPv4 header can be varied. So of course, if you have most probably that is not going to change the data size. If you are dealing with the normal network environment, with the normal network traffic, of course, that is going to be the 20 bytes. But it might be vary based on the different options available with the IP, enable with the IP version 4 headers. So that can be goes up to the 60 bytes. And the plus the real data, that once you added up both, so that is going to give you the maximum transmission unit that you can set out is 1,500 bytes. Is it clear, guys? Is it clear? මේක තමයි කරන්නේ. Maximum MTU value එකක් තියෙනවා දීලා, එතකොට යන්න පුළුවන් maximum transmission unit එකක් define කරලා තියෙනවා. යන්න පුළුවන් maximum transmission unit එකේදී අපි කියන්නේ maximum යන්න පුළුවන් ගාන කීයද කියලා. So there are concerns like that. So they will be saying like maximum transmission කියන්නේ මේක 1500 තමයි යන්න පුළුවන්. 1500 යන්න පුළුවන් කියලා කිව්වට 1500 ට අයිති වෙනවා ඊතර්නෙට් හෙඩර්ස් අයිති වෙන්නේ නැහැ. ඊතර්නෙට් හෙඩර් එක වෙනම පස්සේ ලේයර් එකකදී ඇඩ් වෙන්න ඉන්න. ඒක ගැන අපි මෙතන කතා කරන්නේ නැහැ. හැබැයි මේකට ඇඩ් වෙනවා actual data. කියන ඇත්ත data ටිකයි ඊට අමතරව header size එකයි IPv4 header size එක. දැන් ඔයාලා ඩීල් කරද්දි මෙතෙන්දී actual data මොකක්ද වෙන්නේ? actual data තමයි ඔයාගේ ඇත්ත data ටික. ඒකට add කරන්න ඕනේ 20 bytes. ඔය දෙකේ එකතුව තමයි හැමතිස්සෙම තවුනොත් data packet එක යවන්න බෑ. ඒ හින්දා හැමතිස්සෙම මේ තියාගන්න v4 header එකයි real data එකතුව තමයි 500 වෙන්නේ. එතකොට ඔයාලා කිව්වොත් එහෙම මගේ data size එක 4500 bytes කියලා data මෙත plus IP header එකට plus the 1480 bytes මේක තමයි වෙන්නේ 20යි 1482 දෙක ගැටෙනවා එක data packet එක මෙතනින් හැදෙන්නේ 1500 bytes හැබැයි මෙතෙන්ට if you look at what we the data size that we have included 1480 yeah? Not the 1500 because that is the IPv4 header. So now in this data packet, if you look at the actual the two flags, do not fragment and the M fragment, more fragmentation. Of course, we require more fragmentation. So do not fragment has to be disabled and more fragment has to be enabled because we require more fragmentation. The second data packet, that's again we are going to take the 20 bytes of IP header, which is going to added by the IP layer, and the next part will be filled up with the data of 1480 bytes. In here also you can see that the defragment or the do not fragment set the value will be set to 0. More fragment value will be set to 1. Guaranteed, that is what they are going to do. So now you can see 20 bytes plus 1480, 20 bytes plus 1480. So you will be able to see how many data that we have consumed. 1480 plus 1480. Now we have consumed 2960 data. So there were so many again. There was something else like, then again we are going to do the another fragmentations which including adding the 220 bytes of header by again we are taking from the also make a defragment, do not fragment. There we don't want to do a more fragment. A do not fragment has to be 0 and more fragment has to be 1. So now if you look at here, again we have added another 1480 bytes of data. So now you can see 4440 bytes. So there is another 60 bytes remain. For that we are going to add another 20 bytes of, because every time when you defining a data packet, definitely it should add the 20 bytes of IP header and the 60 byte of data. The rest of the 60 bytes. In this data packet we said, because from that point onward we don't want to do any fragmentation. More fragment has to be 0. So this is the B flag and M flag with the fragmentations. Now clear guys. Then make a තේරුණාද?
Yes.
What about the others? අනිත් අයට මොකද තත්ත්වය? Just මේක මේ පොඩි calculation වල වැරද්දක් තියෙනවා මම මේක හදලා කරන්න. 5140 bytes. හරි. මේ ටික තේරුණාද? Guys, what about the others?
Yes, sir.
Yes, sir.
So hope the people who were dealing with the Tamil language also, they were understood properly. This one, let me check who. Sorry, guys. Uh, Fatima Rikasa, how about you? Are you clear?
Yes, sir.
Okay, great.
සර් ඔතන ඔය තියෙන සර් ඩේටා ප්‍රමාණය විතරනේ ටෝටල් ලෙන්ත් එක තිබ්බොත්
Total length එක තියෙද්දි
හෙඩර්
20
සෙට්
අඩු කරන්න ඕනේ.
එතකොට සර් ආයෙ අර එකතු වෙද්දි 20යි බයිට් 20යි බයිට් එකතු වෙගෙන යනවද
නෑ නෑ මෙතන මේකේ වැරද්දක් තියෙන එක total length එක එහෙම දෙන්න බෑ ඔය වැරදි ඇත්තටම. data packet එක total length එක 5140 වෙන්නේ කොයි වෙලාවෙත් ඔය data size එක දීලා තියෙනවා.
ඕකේ සර්
Sarat Shaba, are you clear? Raise moment. Are you clear? Who is this soft 18? Tharmi. Are you clear, guys? Who is this
Yes, sir.
device one?
I can understand.
You can understand, right? Triple A Ahmad. How about you?
Yes, sir. I can understand.
Sorry?
I can
I didn't
understand.
hear you. Okay, great. Triple A Ahmad. Galaxy M31. Who is this Galaxy? I'm from another Galaxy. Galaxy M31. Right. Okay. Great, guys. So, Niroj, waste time. Yeah, Nirojini, do you have any issues?
No, sir, I understood.
Okay. Right. So, okay. So from this, we'll continue with the rest. So I'll take this particular example here because need to understand, need to get the idea on the fragmentation offset. So actually the fragmentation offset is a what actually in layman term, if I explain it, it is type of a demarc point, like demarc point in the sense you should give the exactly where you are breaking your chunking your uh, data packet. It's like a sort of a boundary. We have to exactly tell this is the boundary of the first data packet, this is the boundary of the second data packet, this is the boundary of the third data packet. So that sort of a demarc position that we are going to clear, or we are going to give it with the simply with the fragmentation offsets. Are you clear this one? Just a simple layman things, like when you let's say for example, if you have a bare land, or bare, you're not even the bare land, let's say just you have a land, whenever you want to mark your boundaries, so you need to like either you have to build up a fence, or you have to build up a wall, or what you need to do is you have to say anyway build up any type of a marking point, and you have to separately you have to mark that as your boundaries. So this is exactly what we are going to do, because it will be help you to rebuild the packet. Let's say, for example, the reason why we are going to say is, now we have identifier. Let's say, for example, whenever you are dealing with, I have told you that each and every data packet that they are going to identify through identifier. Let's say this is the identifier packet 100, same identifier will goes to go. So all the 4 data packet, we have a same identifier, because I told you that even though number of chunking or the fragmentations that you use, that doesn't make any sense. So you have the same identifier. So if you do have the same identifier, when you receive at the resemble point, that means the receiver end, how they are going to see, look at, okay, what is the first data set that we need to collect first, and the second data packet that we need to collect second, reassemble in the second position, third data set that we need to reassemble in the third position, fourth data set that we need to reassemble in the fourth data set. So we need to have clear idea. We need to look at what exactly we are going to do. What exactly we are going to do. Are you clear, guys? ඩීෆ්‍රැග්මන්ටේෂන් කියන එක නෙමෙයි එතන තියෙන්නේ හසිත. එතන තියෙන්නේ මේ do not fragment කියන එක. do not fragment එක දැම්මොත් එහෙම එතනින් එහාට ඒක fragment වෙන්නේ නැහැ. ඒ කියන්නේ ආයි තවදුරටත් fragment කරන්න ඕනේ නැහැ. දැන් මේ data packet එකේ මෙතන defragment එක do not fragment කියන එක defragment නෙමෙයි do not fragment. D stand for do not fragment. Just a second, guys. Right. So the D stand for not the defragment, do not fragment. M stand for more fragment. More fragment. So D, when you say D, that is do not fragment. When you say M, that is more fragment. What exactly they are going to do is they will be going to sort of going through a fragmentations, like do not fragment කියන්නේ එතනින් එහාට ආයි fragment කරන්න එපා කියන එක. more fragment කියන්නේ අපිට fragment කරන්න ඕන කියන එක. දැන් මෙතන අන්තිම data packet එකේදී ආයි අපිට ඇත්තටම fragment කරන්න දෙයක් නැහැ නේ. ඔක්කොම data ටික fragment කරලා දාලා ඉවරයිනේ data packets වලට. ඒතර මෙතනින් එහාට ඕනේ නැහැ. ඒකයි do not fragment එක වෙලා more fragment එක බිඳුවේ. තේරුණාද ඒක? හසිතට තේරුණාද? Right. So the D and M flags that we have used in here, that is exactly what we are going to do. So now next thing that we will be look at it. Now here, just as I mentioned, so how we are going to deal with, okay, what is going to be the first data packet, what is going to be the second data packet, what is going to be the third data packet, and what is going to be the fourth data packet when you reassemble the data packet in order to reconstruct the data that reconstruct 4500 bytes of data. So if you recall, what is the method that we are going to do in here? Because obviously based on the identifier you can't reconstruct the data, because it does not have a sort of a demark point and says what is the first packet, what is the second packet, and what is the third packet, and what is the fourth packet. If they have again shuffle the packet order, of course you will be getting a corrupted data. That is guaranteed. That is guaranteed. So what they are going to do here is, that's where we use in the fragmentation offset. this is where we are using the fragmentation offset. Fragmentation offset that defining where we have fragmented data packet. Let's say, for example, in this case, the fragmentation offset will be start with the 0 value. So we says this is the zero, the packet will start with the 0 value. The next packet, so obviously there is 1480 bytes, because since they are not dealing with the bytes, they will be dealing with the sort of bits values, sort of a exact markup place. So if you divided this one, මේක අර bytes bit කරන කතන්දරේ නෙමෙයි, නමුත් අපි අටෙන් තමයි මේක බෙදලා ගන්න. 185. So the next demarc value that we are going to use here is 185. Next value is දැන් ඉතින් මෙතෙන්ට තව 185ක් එකතු කරන්න. මෙතෙන්ට තව 185ක් එකතු කරාම sorry 185 plus 185 370. එතකොට මේ next one will be divided from the 370. The next markup value for this one 370. So the next thing is going to be the, again we are adding another 1185, that is going to be 555 555. So these are the markup values. Along with that, they are going to add the sequence number. Let's say, for example, 0.0, so 0-0, and then they are going to divide in here. They are going to say like 0-1 packet, 0-2 data packet, 0-3 data packet. So these are the different type of values that we are going to use it in here. So this is what exactly we are going to deal with the fragmentation offset. So where we demark the exact location. We demark the exact location. දැන් එතකොට මෙයා බිල් කරගන්න දන්නවා identifier C මේක තමයි 0 layer එක 185 370 555. ඒ කියන්නේ මේ තැන් වලින් තමයි layers. So these are the level there they have break the data. They have break the chunk. They have chunk the data. So that is called fragmentation offsets. Are you clear, guys? Do you have any issues so far what we have done? So you can see that exactly fragmentation offsets. You can see the identifier, it's going to be unique identifier number. Guys, are you clear? Of course, for your exams, this offset will not much important, but you just get the idea how it is going to be and why it is going to.
Sir, පොඩ්ඩක් ආයෙ පැහැදිලි කරන්න පුළුවන්ද?
Offset එකද? Fragmentation offset එකද?
Offset එක offset.
Right. So I'm going to explain it again. Right, guys. So I'll explain it again. Keep in mind this one. So the fragmentation offset. So as I mentioned you, there is identifier. So if you look at this particular data packet, the identifier will be the same. That is to identify that it's from the same data packet, like your surname. So whenever, let's say for example, in order to identify that you are from the same father, so there is a surname, simple as that. So you have sister, brother, and everything has a surname, carrying out the family name simply as the family name. That is like identifier to you guys. Is it clear?
Yes, sir.
Guys, okay. So the fragmentation offsets, what exactly says here is where you have broke your package. Fragmentation offset, where you have broken your package. So definitely the first packet will be the 0, and from that they are going to be multiplied by the 0, and then again 185, then again 370, then again 555, then again another adding of 185, let's say for example, sorry, 5555 plus 185. I'll explain why those are the frag of the packet, mark of the packet. So the reason why they are going to divide it like the 185, that the value that they have taken is, keep in mind that fragmentation offset will always goes with the 8 bytes of chunks. Fragmentation always goes, offset will goes of 8 bytes of chunk. ඒකයි මෙතන හරියට මේ 1408 බෙදන්න. So it's always the 8 number multiplication will be there. So 8 number multiplication always will be there. So that is why the first offset will be here. The first offset always will be here. The first offset always will be here like so guys, so always will be here 0. The second offset always will be here 185. That is where they mark it. That is where exactly they are going to chunk the data. So 0 to 185, that is the first packet markup. 185 to 370, that is the second packet markup. So likewise they are going to have it. The third one is the 555. So from 555 onwards until up to end of this, so that is going to be the 1 2 3 4th markup. So you can see now you have a different markups, so which is we call as a fragmentation of, this is just a sort of a wall.
එතකොට මේ ඔය 0.185 370 කියන randomly ගන්න
හැමතිස්සෙම හැම data packet එකම offset වෙන්නේ මෙහෙමයි.
ඔය numbers වල විතරයි.
මේ numbers එක විතරයි.
හරි හරි.
මොකද 185න් තමයි යන්නේ. ඇයි 1480 නේ maximum වෙන්න පුළුවන්.
ඒ කියන්නේ 185 නියදයක් වගේ තියෙනෝනේ.
ඔය constant value එක, constant value එක.
හරි සර්. thank you.
Clear?
Oh sir.
What about the rest, guys? What about the rest? Others, are you okay? Do you have any problems, issues with this? No, right?
So එතකොට ඔය බිඳුවේ ඉඳන් 184 දක්වා රේන්ජ් එකක්ද පළවෙනි
පළවෙනි එකට එන්නේ. මේක වැරදි guys. මෙන්න මේකේ තියෙන ටික වැරදි. අතර මේක ඔයාලා ඉග්නෝර් කරලා දාන්න. To discuss here is on the header is like we have discussed the second layer of the header, time to live protocols, header checksums. So the time to live, what exactly they are going to do is, it's something like this. Sometimes for a data packet, let's say for example, if the world, let's take a simple example, if the have been become immortal, what will happen? Of course no one goes going to die. That means simply no one going to die means the population will continuously increase, and then we won't be able to exist in the world. That like there will be sort of issues with the, because all the people from the 19,700, let's say 1,600 from the day that the world begins, So until up to the now, the animals, people, everyone will exist. So that is like a sort of a loop. So in the IP datagram also, we do have issue like when you dealing with this time to live values, what we are having is the data packet that can exist a lifetime for the data packet. Normally, if it is says that it says the 8 bits value, that actually the time TTL value for the IPv4 address here is IPv4 data packet is 255. That means whenever the data packet passing through a router, they will be going to reduce the number one by. They will deduct the number one, but they will deduct the 255 by one. So let's say if the data packet passed to one router, that the TTL value for that particular data packet will be 254. Once he reached to the next router, the TTL value for that particular data packet will be 253. Once he reached to the next router, the data packet will be 252. Next router 252. Likewise, the data packet will, once it is reached to the zero, the data packet will be discarded. Reason is, let's say if you send a data packet where the destination is actually said, the will be looping within the networks without having the destinations, like a zombies. There is there's a stage in our life we like a zombies, right? We don't have any ambitions, we don't have anything, so we just roam around, just something like that. So that is the exactly the what will happen if you didn't define the time to live value, TTL value. So that particular data packet will be zombie. So just imagine millions of users are using the internet and millions of users are sending a data packet, one data packet. Just think about one data packet, which is that data packet does not have a TTL value and it's going to the unreachable destinations. Exactly, data packet will be looped if they don't have the TTL value. That means it's a sort of a DDoS attack again in the network. So the reason why they have introduced the TTL value for the IPv4 data packet also, that is to destroy at some point where if you address the unreachable destinations. Are you clear, guys? So the data packet will deduct one when they passing the routers, router or the multi-layer switches. They don't deduct the TTL value while they passing the switches, layer 2 switches. They don't deduct the values. Only they need to pass through the network layer devices. There are two type of network layer devices. One is the routers, the second one is the layer 3 switches. So if they are going to pass those two only, they will going to deduct. Is it clear, guys? Okay. Okay. So that is called TTL. That is called TTL. Protocol in the sense, what exactly I'll show you the protocols. There are different type of protocols that we can use. Yes. ඇහෙන්න. කැඩි ඇහෙන්න. ඒත් මට ඇහෙන්න කැඩි.
TT Dynasa
ඒත් කැඩි ඇහෙන්නේ. chat එක දාන්නකෝ මම රෙතර බලාගන්න පුළුවන්. If you put it in the chat.
Okay, sir. Chat එකකට දැම්මා, sir.
නෑ අඩු වෙන අලුතෙන් අප්ඩේට් වෙනවා කියන්නේ data packet එක කොහොමත් router එකෙන් යද්දී මේ data header එක අලුතෙන් ලියවෙනවනේ IPv4 header එක. මොකද ඊළඟ router එකට යනකොට header එක වෙනස් වෙනවා. header එක ලියවෙද්දී අනිවාර්යයෙන්ම මේක අඩු වෙනවා. TTL value අඩු වෙවි යන්නේ.
හරි සර්.
එතකොට TTL value එක අඩු කරනවා. Is it clear guys? Right, so let's look at the protocols, like what type of protocols that they are going to use is they will be using ICMP. This is ICMP stand for actually simply the whenever you want to check the availability of the other end parties, like we will be sending the ping. So we are going to use the ping command in order to send the ICMP request. What ICMP does is it seems other parties availability. These are the four headers. So the last things that we are going to deal here is like then again we are having the header checksums. This is actually most probably the header checksums. What they are going to do is they are going to do a sort of a verification on the data packet. So most probably in most of the time the header checksums is not verified. Actually what they are going to check is are there any errors on the data packet. So they will be verifying whether they are having errors, but actually this header checksums going to not work because there are so many other error control mechanisms available in the TCP IP stack where it does not want to rely on the header checksum values. So most of the time, as I show you, it says not verified in the sense they are not going to verify the header checksum, so they are not going to check for the errors in the IPv4 header or in the IPv4 layer. So the last two things is the source IP address and the destination IP address, whom you are the person who's sending it and the person who's receiving it. So the source is the whom you are sending it, the destination is the whom you are receiving it. So the rest of the things, options, once you've done it, just that is later. Right, guys. So if you have any questions, guys. Okay. So now it goes up to the 62 participants. Nothing to worry. So So then shall we start the assignment? So it's 7:15. 63 participants is there. So let's start the assignment. Right, okay guys. So we'll start the assignment. So first question is for the day. So you can start the assignment now. So this is the first questions. If you can just write it down the questions, then I can go through the different other questions as well. So we have 1, 2, 3, 4, 5, 6, 7. 7 questions available. So mark it with the 10 marks. Guys, once you complete, please let me know, then I can go to the next one. Guys, so shall we go to the next slide? Guys, okay. So what about the others? Shall I move to the next slide?
Okay, sir.
Right. So the next slide will contain another 3 questions. So guys, you need to send all the answers together with your index number and everything. So shall we move to the next one? So the next slide, that is the...
Wait.
Okay, just write it down to questions. That is enough. Then you can, you will be having a time, no worries. So I'll give you, once you complete the write it down, I'll give you another 20 to 30 minutes to complete your assignments. Nothing to worry about it. So have you done, note it down your questions? So I'll give you another 2 minutes to note it down this one. So then I'll move to the next one. Okay, guys. So let's move to the next slide. So that is the last, I guess, yeah, that is the last 2 questions that you need to go through. So please note it down. Then I will give you time. How about the status, guys? I am receiving answers from the different people actually. So hope everyone has sent the answers. Is that so, or are there any pending? So it's now almost close to the 8:20. So just let me know if you need more times, guys. So otherwise I will be going to close the session. And okay. Guys, someone have sent the answers, but just only the answers. So if it is having the calculation, I need the calculation as well, because some are having giving me answers with the calculation, so nothing to worry about it. So I will give you another 10 minutes. So definitely I will be going to close the session on 8:20, yeah, 8:30. Right, okay, guys. So we are going to wind up for today. So hope everyone has sent me the answers. So I will be marking up your answers today evening. So we'll going forward this one. So guys, please don't send me the answers through the WhatsApp because that is definitely not practical to look at by myself. Six questions in the sense you will be only able to send for the question number only up to the question number 6. Yeah, you can't attach anything to the chat. That is obviously not possible.
Sir, I sent 1 to 6 and then I copied balance.
Okay, no worries. So, but on the balance also, you should mention the index number.
එහෙනම් කොටස් දෙකකට එවන්නද?
කවන්න එවන්න ඉන්ඩෙක්ස් නම්බර එක දාලා එවන්න එහෙම උත්තා. කොටස් දෙකට එවන්න. කවන්න. But on the both answers, you need to mention your index number.
Okay sir.
Images නම් එවන්න එපා මේ කට්ටිය images එවන images එවන්න එපා images මට ගන්න බෑ මේක අරගෙන කොහොමද view කරන්නේ. So if you want to send the even WhatsApp, then you have to send it as a txt file. Don't send the images, huh? Don't send the images. Because I won't be able to mark it.
සර් WhatsApp එකේ PDF කරලා එවුවොත්
PDF කරලා වුණත් කමන්නේ එවන්න. PDF හරි TXT හරි එවන්න එහෙම ඔයාලට එවන්න බැරිම නම් නැත්තම් රිෆර් කරන්න ඇත්තටම chat එකයි. මොකද මම chat එක save කරලා එතනින් තමයි බලන්නේ මට ලේසි ඒක offline බලන්න පුළුවන්. Otherwise, there's a high chance of missed your answers. That's the case. If you send through the WhatsApp, so it's a high chance of missed your answers. That's the main issue. That's why I'm telling that send through the chats.
Sir,
Yes.
can you see both answer in private section because I sent it
So that's
to private.
it's a SOF19B120.
No, I'm 13 net.
So I can see the answers on 2018. කොයි වෙලාද අය ගෙව්වේ? 31 net.
No sir, 13.
13 net 13th.
Yes sir, 13.
When did you send the answers? Because recently, very recently, that means I'm checking on 8:30 p.m. and 8:32, 8:33. I didn't receive any answers on that.
No, I sent before 8:30.
Then definitely that will be there. Nothing to worry. So if you are sending to me. Okay, guys. So
hello sir, receive MMW B180 answers.
yeah, when did you send it? Because I'm not. I can't check everything right now. B118.
Yeah,
Yeah, that is there. B180 is there. That is
separately I send it.
1 to 3 and 4 to 7 also.
I have received, yeah, yes, I have received those things.
Okay, sir. Thank you.
Okay, guys. So this week we are not going to have another lecture. So definitely we'll meet on next week. Next week I'm going to start the another one on that is the we are going to start IPv6. Of course, that again we'll go through 2 to 3 lecture sessions as I mentioned. So that is going to discuss about the IP version 6, and there will be another 2 lectures. Most probably we'll have another 5 lectures to complete your syllabus. So that is the plan that we are having for the next couple of weeks. So within next 5 weeks period, most probably like 2.5 hours question exam the 2.5 hours of lecture sessions. So we going to have the all together we are going to have the lecture. So the to complete the lecture. So rest of the 2 chapter that we are having is routing and the IPv6. Next week we are going to definitely start the IPv6 addressing scheme. So I will send you the Zoom links and so once we complete the IPv6 again within the IPv6 class sessions, the sessions there will be one assignment. So most probably about the sort of a 5 marks assignment. So it's a small assignment that we are going to go to. So these two, that previous two, this one and the previous one was a two important assignment because this will get 10 marks and the last one has been taken 15 out of your 40 of your assignment marks. So we'll meet on next most probably next Wednesday as usual in this timeline, and let's say 5:30. Let's have it sort of a time fixed time like 5:30, and we go around until up to 8:30 like this. So and we'll complete the your lecture sessions. So most probably we will be able to complete your lectures within second week of the December. So that will be giving you the completion of your exam. So the assessment as well. Okay,
Sir, is
guys.
it possible to conduct the semester exam end of the December?
I'm not quite sure because that is the decision is going to taken by the Senate and the department head of your university, because I'm not the person who's taking those decisions basically. So they will definitely let you know about their future plans, how they are going to conduct the exams. Sometimes it might be because of this current situations, this pandemic situation, this your exam is must be going to have the sort of online type of a exam environment. Most probably, I'm not quite sure because it is not possible or practical to have it exams on a sort of a what we call in the whole type of a exam environment. So definitely that is going to be a most probably will be going to be online type of exam that they are going to help, but I'm not quite sure what are the decisions that they are going to take, because it's the faculty board and the vice chancellor and all of the authorities, they will take the decision on regarding that. So, okay guys, so we'll meet on next week, most probably the next month by Wednesday we are going to start the IPv6 addressing. So
Okay, thank you,
stay
sir.
safe guys, have
Okay,
a
sir. Thank you very much, sir.
yeah,
Be safe.
have a
Yes, sir.
great week and stay
Thank you.
safe.
Thank you, sir.
Good night.
Thank you, sir. Good night, sir.
Okay, good night, sir. Bye.
You good next.